So, good morning. My name is Roshan Ahammed. I am here to discuss about a topic ultrasonic welding. So let's get into the topic. Ultrasonic welding is an industrial technique whereby two pieces of plastic or metal are joined together seamlessly through a high frequency acoustic vibration. So the component to be welded is placed upon a fixed angle, and the second component being placed on the top. An extension connected to the transducer is lowered down onto the top component, and a very rapid low amplitude acoustic vibration is applied to a small welding zone. The acoustic energy is converted into heat energy by friction, and the parts are welded together in less than a second. So it is a technique based on connecting because connective bolts, nails, solder materials, or adhesives are necessary to bind the two parts together. So this saves on manufacturing costs and creates unnoticeable seams in products where appearance is important. It is a largely automated process, but it is only applied to small components such as watches, cassettes, plastic products, toys, etc. Because, for example, if we take a chase of an automobile, as the part is very large, so it is need a high energy to weld this automobile through ultrasonic welding. So it is not possible. So when bonding material through ultrasonic welding, the energy required comes in the form of mechanical vibration. So the welding tool couples to the part to be welded and moves it in longitudinal direction. The part to be welded on remains static. Now the parts to be bonded are simultaneously pressed together. The simultaneous action of static and dynamic forces cause fusion of the parts without having to use additional material. So this procedure is used on an industrial scale for linking both plastic and metals. So these two figures shows the difference in the process of welding plastic and metal. So the figure the part one shows the anvil, the part two is the welding material, part three is the sonotone, and part four shows the oscillation of the ultrasound. So let's look into the parts of a welding equipment. So the first part of the ultrasonic welding is a frequency converter. So this frequency converter is used to convert low power into high frequency electric power. So the second part is transducer. This transducer is used to converting high frequency electric power into a vibrating energy. So the frequency converter converts the low frequency to high frequency, and this transducer convert this high frequency into a vibrating energy. So the next part is the horn. The transducer converts the high frequency to vibrating energy. This vibrating energy is concentrated to the to the welding zone using this horn. So the next part is anvil. So the anvil is used to support the welding materials. So the two welding materials are placed on top of one of the another. Uh, Next, like the ultrasonic welding process. So the both surfaces are kept together, and the one of the material usually has a spiked energy director which contacts the second plastic part. So the ultrasonic energy melts the point contact between the parts, creating a joint. The oscillating is given by transducer to the second sonotone. So in thermoplastic, the vibration range is from 50 kilohertz to 70 kilohertz. And in thermoplastic weld occur by reaching local melting point of the plastic due to absorption of vibration energy along the joint to be welded. But in case of metals, welding occurs due to high pressure dispersion of surface oxides and local motion of the materials. Although there is heating, it is not enough to melt the base material. So as in this video, we can see that uh, the horn is concentrating the ultrasonic vibrating energy into the welding zone. So due to that concentration, a friction is happened between those two materials, and due to that friction, a heating source is generated, and due to that heat source, the two metals get welded together.
Good morning. My name is Mohamed Abdul Jaleel. I'm going to take the rest of the topics from here. First topic is ultrasonic welding mechanism. So mechanical vibrations moves one part against the other under the pressure. This disrupts the oxide layer of both the materials, and the atoms from the surface of the metals get diffused one part of to the other when the oxides are dispersed. Since no oxides are now left at the interface, a true metallurgical bond is achieved. This is the mechanism of the ultrasonic welding. Next is the applications of ultrasonic welding in different industries. First is the automobile industry. In automobile industry, it is used to assemble large plastic and electric components like instrument panel, door panel, lamps, air ducts, etc. It is also used in diesel injector, universal joint yoke, and the gear hub. Next application in the medical sector. It is in the medical sector. It is used to weld different types of filters, IV, catheters, dialysis tubes, pipettes, cardiometry reservoirs, face masks, etc. Items like hospital gowns, sterile garments, masks, etc. are also welded using this ultrasonic welding. Next is in the packaging industry. Explosive, fireworks, etc. Next is the application of ultrasonic welding in the packaging industry. Explosives, fireworks, etc. These items require hermetic sealing and they can't be exposed to high temperatures. Butane lighter, food packaging, milk and juice containers, etc. are welded using this ultrasonic welding. Paper parts to be sealed are coated with plastics, generally propylene or polyethylene. Next is the application of ultrasonic welding in aerospace and marine industry. In aerospace and marine industry, wire terminations and splicing in electric and electronics industry are done using this ultrasonic welding. They are also used in twist drills, drill pipes, spindles, tapers, etc. Next is the advantages of the ultrasonic welding. The first advantage is that there is no need of any external heat generation for this ultrasonic welding. Two dissimilar materials can be joined using this ultrasonic welding. The heat affected zone is very small in ultrasonic welding. Surface deformation is less and there is no waste materials generated. Very thin materials can be welded and weld is localized to a small space. No defects due to gases, arc, or and filter metals. Welding time required is minimum. It is lower than 3 seconds. Next is the limitations of the ultrasonic welding. The limitations are the thickness of the component adjacent to the sonothrode tip must not exceed relatively thin gauges because of power limitations of the equipment. It is comparatively expensive techniques when compared to other welding techniques. It is used for small pressure conditions because they cannot withstand higher stresses. Only thin and soft materials can be welded using this technique. Thank you.